We're diving deeper into sizing and selecting your own mechanics. We talked about a lot of terminology you need to know about back in episodes 3 through 8. Now we're going to dive deeper into each of those and kind of bring it together. I'm Corey Foster at Valen Corporation. Let's see what we can learn. If you like what you're learning, follow #MotionControlShow and check out this link here. So let's jump into summarizing LOSTPED. LOSTPED is an acronym that is used in the industry, where the LOSTPED stands for Load, Orientation, Speed, Travel, Precision, Environment, and Duty Cycle. But in each one of those, there's a lot to it. For instance, if I ask you for the load, you might just give me 1 pound. But I need to know more about that 1 pound. Where is it located? What's the orientation? How fast are you moving it? How far do you need to move it? But even that 1 pound, I need to know a lot about it. So what does LOSTPED really mean? Okay, so let's talk about the first two, load and orientations. Remember, if you go back to an earlier episode, force equals mass times acceleration, and moment equals force times distance. So if we look at that and what load and orientation actually mean, here's an example of a simple diagram of an actuator where here's the load in the middle, and if it's off center, that ends up creating some moments. So it's not just about the load down, but it's about where that's located and what moments it can cause. Now, I'm not going to go into all these equations, but different scenarios will cause different loading. So we'll talk about static loading sometimes, which is the load while there's no motion. So just sitting here, this 1 pound is 1 pound down on the stage. But while it's moving, that can cause a dynamic load because the mass times the acceleration can cause a force. And so, for example, here are some catalog specs from one manufacturer, and it talks about moment A, moment B, moment C, and those could be X, Y, Z for that matter. And it talks about the allowable overhang. So this is just an example that one manufacturer will, actually all of the stage manufacturers will give you some sort of dynamic loading. And so that's what it looks like. And again, this is all based upon the load, the bearing life curves that I talked about back in episode 8. So here's one orientation. So it's just horizontal. We have a load, but when this load is sitting on top of this, it creates a static load. But when you start moving, it can create an acceleration forwards or backwards, which causes a moment loading. So here are some equations for this orientation. And if that load is way off here to the side, it can cause some other loads. Again, I talked about these in the earlier episode, I believe, but that's what the load and orientation aspect of LOSTPED is. And if we look at this one, we'll get some more loading here. And if you get vertical with it hanging off, again, you get a moment loading this way. These are all the equations involved. Speed. Now speed is an interesting thing because people will say, I need to go 1 meter per second. Okay, I need to go 1 meter per second. Does that mean you care about making sure you're at 1 meter per second? Or you want to move 1 meter in a second? Because if we look at a curve here, this graph, velocity versus time, distance is the area under the curve. Well, acceleration is this ramp here. Now, if we do a constant velocity the whole time, this acceleration is instantaneous. But if we want to make this acceleration ramp more of a ramp as opposed to instantaneous, which is not possible, then we're going to end up with a higher speed if we want to keep the same distance and area under the curve. If we want to go a lower acceleration rate, then we might end up with a higher speed to keep that same distance under the curve. And this is called a triangular profile. This is called a trapezoidal profile. So again, if you say you want to go 1 meter per second, do you care about moving 1 meter in a second? Or do you care about the actual 1 meter per second? You don't care how long it takes to get there or how long you actually move. What is important? And then if you really care about smoothness, then we might be taking a look at an S-curve profile in order to reduce the amount of jerk caused by the points where the acceleration changes. In which case, we end up with a really steep acceleration ramp here, which is more force or torque at the motor, and so we have to take that into account. So the speed really has to be about the motion profile. It has to be defined with possible accelerations, distance versus time, what's important. And oftentimes, I'm just asked, I want to go this speed. So we've gotten through the LOS of LOSTPED. Let's take a look at T, the travel or the distance. What's the real distance requirement? Some people will talk about the length of the actuator. I need an actuator that's 1 meter long. Or I need to move a travel that's 1 meter. Well, depending upon your stages or your actuators, these numbers can be a little bit different. For example, some actuators, we have to define a safety margin or an over travel margin. So that 1 meter of application requirement might be here in the middle, and there might be, let's say, 100 millimeters on each end. That means now we're looking at 1.2 meters of travel. Now the overall actuator is, I don't know, closer to 1.4 meters. So when you say the distance, what is the actual distance you're talking about? If you define a 1 meter of travel, hard stop to hard stop, you may have a hard time using that full 1 meter in your application. So you have to take that end of travel into account. And precision. I had a whole episode on this back in episode, episode 4 it was. What's the real precision requirement? I talked about resolution, talked about repeatability, and I talked about accuracy. And you can go back and look at that for more in details, but what that actually means in your application is hugely important. And there's a lot of components that affect the precision. Don't forget those. Got to go through. There's the encoder, there's possible gearbox, belt and pulley, coupler. All the products there affect the precision in the end. Don't forget all the types of precision. I talked about linear, rotational, the Abier, straight line, orthogonality, concentricity, run out, rotational wobble. And of course, where is the point of measurement? Is it at the actuator itself? Is it an inch above? Is it 2 inches above? Is it off to the side? Where is that point of measurement that's actually important? And then the E in LOSTPED is the environment. Now, for a lot of people, this may not seem important, but there may be a washdown environment where there's fluids that cause rust and corrosion. It may be dusty and dirty, which can cause the mechanics to gum up and jam. It may be a vacuum, which causes plastics and other materials to outgas. It may be extreme temperatures, which causes materials to freeze or melt. Or radiation, which causes decay of materials. I've worked in mechanics and other products through all these environments, and these are a lot of things that we come up against. If you have no extreme environment, then it doesn't matter. But it begs the question, what's your environment? And then the last one is duty cycle. Duty cycle is something people forget about because they'll just think about this motion profile. But there could be a dwell time after it. And so if we look at a distance here, maybe you're moving out and then moving back, this time in between moves gives you a dwell time. If you're moving out and back with no dwell time in between, then you have a 100% duty cycle. But if you're moving out and waiting, and then moving back and waiting, your duty cycle goes down. And that changes the lifespan of your mechanics, changes the actual torque requirements on the motors, so it makes a big deal. I hope that summarizes LOSTPED and kind of packages everything in nicely into one episode for you. I think it'll be a good point of reference in the future. So remember to follow my hashtag Motion Control Show and check out this link for other episodes. Thanks for watching. I'm Corey Foster at Valen Corporation.